Okay, Unit 10 is about area. So this is not on your note taker, but just watch what I do. I just want to talk a little bit about what area means and how we figure out how much area a particular shape covers. So area is, like I just said, area is another way of talking about how much space something takes up. So if I want to know the area of this rectangle up here, I need to know its dimensions. In other words, I need to know the length of its height and the length of its base, right? Or I could call that, I could also say I need to know length and width. Okay, so I need to know something about how big this rectangle is. Once I know that, I can figure out its area. So let's say the height of this rectangle right here, let's say the height of this rectangle is 3, and let's say the width is 8. And I want to know what the area is of this rectangle. All I have to do is multiply the base times the height. So in this case, that would just be 3 times 8, and 3 times 8 is 24. So 24 square units would be the area of this triangle. Let me show you why that works. If I know that the height is 3, then what I'm saying is there are 3 pieces that are all the same size going that way, right? Each one of these is 1 unit tall. If there's an 8 down here, what it means is that I can divide the same rectangle into 8 parts going left and right. And so then if I went through and I counted up all these squares, I would get 24. But basically the idea is if you know the base and the height of a rectangle, you can calculate its area. Same goes for squares. If I knew that this square was 10 by 10, I would just multiply those together, which I know is 100. Okay, so that's not on your note taker. It's okay if you want to sketch this on the back, you can, but you don't have to. So now let's actually get into chapter 10. First type of shape we're going to calculate the area of is a parallelogram. So remember, a parallelogram is a shape where both pairs of opposite sides are parallel to each other. So what we're going to do first is talk again about how it works with a rectangle. So if I wanted to calculate the area of this rectangle on the left, as I saw on the last, on that other page I was working on, the area is just the base times the height. And so it's going to be this 5 right here times this 12 over here. So the area here would be 12 times 5, or 5 times 12, which is 60. So I know the area of this rectangle is 60. What happens if I make a cut along this along this dotted line, and I take this triangle here and I shift it over here? All right, so what I've done, taken this piece, this triangle right here, and I've just cut it off of this and moved it over to this side. What happens is that I calculate the area in the exact same way. I still know that this right here is 5, right? Because if this side over here is 5, then this side over here would be 5. So I know that the height of this parallelogram would be 5. The base is still going to be 12, right? Because I didn't change anything on this bottom side, right? So if I want to calculate the area of a parallelogram, it would also be 12 times 5, which is still 60. So area of a parallelogram, just think of it as we took a rectangle, we chopped off one corner, slid it to the other side. So even though a parallelogram, which is what I have over here on the right, even though it looks different than the rectangle that I have over here on the left, the way we calculate the area is exactly the same. So I need 2 things. I need the base and I need the height. It'd be nice if it were always that easy, but it's not. Sometimes we're going to get parallelograms that we need to solve for the area for that don't give us both the base and the height. So like on 2a down here, I can see that I have a base. Base can either be the top or the bottom. So in other words, this side down here and this side up here are both bases of this parallelogram. So I know the base, but now I need to know the height. The height is this right here. I don't know that yet, so I'm going to have to figure it out before I can solve for the area of this parallelogram. You'll notice here that I put a reminder of the trig ratios so that we can solve for missing sides within a triangle, because what you can see here is that I have a 45-degree angle inside of a right triangle formed by part of the parallelogram. So what I got to do is I need to figure out x using a trig ratio. So first thing I'm going to think about is, well, what is this side x in relation to this 45-degree angle? It's an opposite. So I have an opposite side which is equal to x, since I don't know what number to put there right now. Then what is this 9 down here? Well, this 9, it's not the hypotenuse, it's not that side, it's going to be the adjacent then. So I know the opposite and the adjacent. So I come up to my list here and I can see that opposite and adjacent is tangent. So I'm going to say the tangent of my 45-degree angle is equal to the opposite over the adjacent. So then I would go to a calculator and I want the tangent of 45. Well, it just happens to be 1. 1 is equal to x over 9. I want to get rid of that 9, so I'm going to multiply by 9 on both sides. So x is just 9 right here. So this side that I didn't know before, this height, is 9. So now all I have to do to figure out the area of this parallelogram is multiply the base by the height. So the area here is just going to be 17 times 9, which is 153. And since we're talking about yards, I would say 153 square yards. That's the area of this blue parallelogram up here. So it's just base times height, but in this case I had to solve for the height before I could do it. Okay, 2b is going to be similar, right? I don't know what the height is. I can see that the base right here is 32. And once again, I have a triangle over here where I only know one angle and I know the length of one side. So from this 30-degree angle, what is x? Well, it's not the hypotenuse. It's not opposite, so it's going to be adjacent. So x here is the adjacent. The only other side that I know is down here. Well, this side is not the hypotenuse either. It's not adjacent to my 30-degree angle, so it must be an opposite. So 12 is my opposite. Once again, I have opposite and adjacent, so I'm going to use tangent. So I'm going to say the tangent of this time 30 degrees is equal to the opposite, which here is 12, over the adjacent, which is x. So first thing I need to know is what's the tangent of 30 degrees. I'm going to round that to 0.58. So 0.58 equals 12 over x. I got to get rid of this fraction. When I want to get rid of a fraction, I multiply both sides by whatever the denominator is. So I would have 0.58x equals 12. Now I got to get rid of the 0.58, so I'm going to divide by that on both sides. So x, which is another word here for the height of my triangle, is just 12 divided by 0.58. So 12 divided by 0.58, which is, I'm going to say let's call it 20.69. So now I know a base, which is 32, and a height, which is 20.69, and to find the area I just need to multiply those two together. So I already have the height in here, so I'll just multiply that by 32, and the area of this parallelogram would be let's just call that 662. And we're still talking, we're talking meters now, 662 square meters. That's the area of this parallelogram.